Hello friend, and welcome to the Sleepy Meteorologist. Tonight, we're drifting gently into a snowfall-swept journey, titled 100 Sleepy Facts About Winter Storms, Meteorology for Sleep. Maybe your day has been long and full. Maybe your windows are glazed with frost. Or maybe you've just tucked yourself in under a blanket that feels like a soft, snowy hill. The world outside might be quiet now. The lights dim, the sky still. How's it looking where you are? Are there clouds gathering like heavy wool, or a faint hush in the air that seems to promise snow? Perhaps you hear the slow whisper of wind, or the nothingness that comes before the first flake falls. Either way, you've found your way here, to a place where the weather isn't just data, it's comfort, calm, and curiosity. If these gentle journeys soothe you, feel free to like or subscribe, but only if it feels right. There's no rush. For now, snuggle in. Let the hush of winter surround you. Let the rhythm of snowstorms and sleepy facts carry you away. Let's begin. A winter storm may look gentle, but every cloud holds immense weight. Above us, in skies that seem quiet and still, snowstorms gather in silence. They arrive like whispers, soft and unassuming, painting the horizon in layers of grey and white. But within those quiet clouds, there is weight, a secret weight, held aloft by the chill of the atmosphere and the grace of natural balance. Tonight, we'll drift into that hidden heaviness, into the physics of snow-loaded skies. Every snowstorm begins in a cloud, those soft, floating masses we often watch from windows or through car windshields. But inside them, millions upon millions of water droplets and ice crystals cling to cold air. A single cubic meter of cloud might hold only a few grams of water. But when the clouds stretch across entire regions and climb high into the troposphere, the numbers become staggering. A full snowstorm can hold billions of tons of water, suspended like a secret above our heads. Its weight you don't feel, but it's there, floating. This delicate suspension is a quiet miracle of physics. Cold air is key. It slows molecular motion, allowing ice crystals to form and cling to microscopic particles drifting in the sky. These particles, tiny bits of dust or sea salt, act like invisible scaffolding, giving each snowflake a place to begin. Around them, water vapor condenses and freezes, growing delicate arms and branching limbs. As more crystals grow and cluster together, the weight builds. The cloud becomes a ballroom of waiting dancers, all in motion, yet not yet falling. The snow-bearing clouds you see, especially the thick nimbostratus kind, are architects of this quiet accumulation. They stretch across the sky, their lower edges often hanging low, heavy with unfallen snow. But why don't they simply drop everything at once? Because cold air lifts. And where warm air meets, cold, an invisible updraft can hold snow in place, almost like a cradle. The colder the air, the better it supports the snow's slow build. Gravity waits patiently, tugging gently at the edges. But eventually, the balance tips. When the crystals grow too heavy to resist gravity's pull, or when the updrafts weaken, the snow begins its descent. Quietly, gracefully. What was once a hidden burden becomes a drifting gift, falling in soft spirals to the earth below. Each flake takes its own path, swaying, circling, responding to the subtlest eddies of wind. It's less a fall and more a dance. This is the moment we often notice, a soft flurry brushing against a window pane, a hush settling over rooftops, the world turning still as the snow touches down. Yet long before it falls, the snowstorm carries its story above us. A story of suspension and stillness, of cold air cradling countless flakes, of water lifted and held until it's ready to come home. So, when you next watch snow drift from the sky, remember you're watching the release of a long-held secret. The sky lightening its load, the clouds letting go in the gentlest way they know how, and here you are beneath it, warm, wrapped in quiet, listening to the weight of winter let itself fall. Not all snowflakes are the same. In fact, there are over 35 known types, each shaped by temperature, moisture, and the path they travel. Snowflakes are sky-written secrets, each one a silent sculpture made of vapor and time. Though they often seem alike at first glance, no two are ever truly identical. Tonight, we'll take a gentle journey through the many forms of snowflakes, listening closely to how temperature, moisture, and movement shape each icy star. There are more than 35 recognized types of snowflakes. Some branch outward like ferns. Others cluster in columns or form fragile plates, rimmed with crystalline edges. The classic shape, the one most of us picture, is the stellar dendrite. With its 6 arms stretching out like delicate fingers, it looks almost like a tiny snowflower. But beyond this well-known design lies a whole spectrum of frozen architecture. Some flakes are needle-like, long and slender, falling quickly through cold, dry air. Others are capped columns, like little ice towers topped with frozen hats. Hollow columns resemble tiny tubes. Sectored plates grow like compass roses, each arm dividing again and again into mirrored patterns. And sometimes the flakes become clusters, groups of tiny crystals that cling together during descent, forming lacy aggregates. All of them begin the same way, as a particle in the sky, kissed by cold. Temperature plays the lead role in shaping a snowflake. Between -2 degrees Celsius and -15 degrees Celsius, different forms emerge, each one responding to a narrow range of atmospheric conditions. If it's especially cold and dry, snowflakes tend to be simpler, columns or plates. If it's slightly warmer and more humid, the flakes grow more complex, branching into starry dendrites. Even a shift of a few degrees changes the design entirely. Nature sketches with precision, but the snowflake's path is just as important. As it tumbles through different layers of the atmosphere, it may pass through zones of warmth and moisture, then back into frost. With every change, it grows in new directions. Its arms lengthen, its edges bloom. Some flakes even begin melting slightly, then refreeze, creating unique rims or caps. This journey sculpts them like tiny travelers, each carrying the memory of its descent. And at the heart of every flake is symmetry, 6-sided beauty, born from the molecular structure of ice. Water molecules, when frozen, naturally arrange themselves in hexagons, a repeating pattern that echoes outward, branching delicately as the flake grows. It's why all snowflakes have 6 arms, yet none are quite the same. They're shaped by order, yet made unique by chance. To the eye, they fall in silence, but to the skies, each flake is a message, a record of air and cold, of sky layers and stillness. So, when you step outside and catch a snowflake on your glove or mitten, pause. You're holding a one-of-a-kind moment, a sculpture made entirely of breath and chill, a frozen blossom from the clouds above. In its shape lives the story of winter's wandering air, a quiet miracle, floating gently down to meet you. Snow doesn't begin as snow. It starts in supercooled clouds. Let's rise gently now, higher and higher into the upper reaches of the troposphere, where the air thins and the world turns cold and quiet. Here, where the temperature often falls below freezing, clouds form not just from water droplets, but from something rarer, something colder. These are the supercooled clouds, soft, suspended nurseries where snow is born. At this altitude, the sky is a different kind of blue, and the clouds, though they appear light and soft from below, are filled with billions of tiny mysteries. Snow begins its story as vapor. Moisture rises from lakes and rivers, exhaled from forests and fields. As it ascends, it cools. Eventually, it meets particles, microscopic specks of dust, sea salt, or even pollen. These particles, so small we can't see them, become the birthplaces of snow. Scientists call them ice nuclei. Around each of these specks, vapor begins to cling. At first, it's just a whisper of frost, barely there. But in the supercooled air, the vapor freezes almost instantly, forming a solid lattice of ice. From that point forward, growth is steady, but delicate. Crystal by crystal, the flake takes shape. This is the quietest part of a snowflake's journey, when it's still held aloft, not yet ready to fall. Cold air slows everything down. Molecules move more gently, more precisely. This slow dance allows snowflakes to grow with astonishing symmetry. Thin branches form, growing outward in perfect hexagons. Each new layer depends on the surrounding temperature, the humidity, the wind, and even the presence of nearby crystals. Like a choir, the flakes grow in harmony, yet each sings a slightly different note. Altitude plays a subtle role. Higher clouds often form simpler flakes, like plates or needles. Lower clouds, with their denser moisture and gentler updrafts, may birth the more intricate stars and dendrites. Pressure matters too. In low-pressure systems, like those that bring wide, slow-moving snowstorms, the atmosphere becomes more hospitable for delicate crystal growth. Gentle updrafts hold snowflakes in place longer, letting them build layer upon layer before drifting downward. Temperature is the most important artist of all. Even the slightest shift, a degree warmer or colder, can change a flake's form. Snow, born at -2 degrees Celsius, may look like a thin plate. At -15 degrees Celsius, it could be a lacy dendrite. Each flake is a response to its environment, a frozen map of the sky it formed in. And then comes motion. Wind nudges the flake from its cradle. Gravity cools softly. As it begins its descent, the flake carries its story with it, etched into every arm, every angle. It drifts from supercooled cloud to open air, falling slowly through layer after layer of atmosphere. It's no longer just ice, it's snow. So tonight, as you rest beneath a snowy sky, imagine the flake's first breath of life. High above, in a cloud so cold it forgets how to rain. In silence and softness, snow begins. Not with thunder, not with force, but with a single speck, a single crystal, becoming more. What does silence sound like? Snow muffles sound, absorbing vibration with its fluffy texture. Tonight, we drift into a silence that isn't empty, but full of softness, of texture, of the hush that only snow can bring. Step outside during snowfall, and you'll notice something immediately. The world sounds quieter. The usual hum of city life, or rustle of forests, becomes distant. Footsteps disappear into softness. Even the wind seems to tiptoe. This isn't an illusion. Snow really does quiet the world. Freshly fallen snow has a porous, airy structure. Each flake traps pockets of space between its arms. And when snow gathers on the ground, those pockets multiply, creating a thick blanket of stillness. Sound waves, instead of bouncing and echoing, get absorbed into that soft texture. They're dampened, slowed, cradled. In acoustics, this is called attenuation. In poetry, it's simply peace. The thicker the snow, the deeper the quiet. A layer just a few centimeters deep can muffle sound dramatically. That's why snowfall at night feels especially dreamlike. Street noises are hushed, voices are gentler, and time seems to stretch. Even footsteps lose their sharpness. Instead of crunching, they become muted pats, like soft drums beneath a thick quilt. In forests, this quiet becomes almost surreal. The trees, heavy with snow, sway without sound. Animals move carefully, their paws pressing gently into powder. The air itself seems to listen. Scientists who study sound in nature often measure the acoustic environment before and after snowfall. What they find is fascinating. The dynamic range of natural sound narrows. Loud sounds become softer, and soft sounds almost vanish. It's a kind of evening out, a return to equilibrium. Even the wind behaves differently. When it moves across snow, the texture of the ground disrupts its flow. It no longer whistles or howls, it breathes. And in this muffled world, your own senses shift. Your ears reach farther, your thoughts slow down. This is why snowfall often inspires feelings of introspection, stillness, and comfort. It's not just the visual beauty, it's the sound or lack thereof. A cocoon made not of walls, but of silence. And the deeper the snow gets, the more profound the hush. On days when the snow falls steadily for hours, blanketing streets and rooftops, the world feels paused, not stopped, just slowed, like a song played in half time, like a dream that's meant to last a little longer. So the next time you find yourself walking through falling snow, listen, not for what you hear, but for what you don't. The gentle hush of the sky, the softened footsteps, the quiet between breaths. This is the sound of winter's stillness, a lullaby made of flakes and air, a silence that isn't empty, it's full of peace. Snowflakes may fall, but not always straight. A snowflake's journey begins in stillness, but rarely stays that way. Tonight, let's follow a flake as it leaves the cold embrace of the cloud and begins its slow descent, drifting, gliding, tumbling, shaped by the invisible fingers of the wind. From its earliest moment, the snowflake is light. So light, in fact, that gravity barely tugs it downward. Instead of dropping in a straight line, it moves through the sky like a dancer, floating between invisible waves of motion. The air beneath clouds is not still. It's a sea of movement, updrafts, downdrafts, turbulence and calm, layered and ever-changing. Each current the flake meets may lift it, nudge it sideways, or spin it gently like a leaf on a slow breeze. This is why no two snowflakes fall in the same way. Some may drift in long, winding spirals, descending slowly through dry, open air. Others are caught in horizontal gusts, gliding sideways for miles before finally touching down. A single flake might take minutes to reach the ground, or linger in the sky much longer, riding loops of air like a paper kite. Meteorologists call this motion turbulent descent, but to the dreaming heart, it's more of a ballet. High cirrus clouds, where some flakes begin, are icy and thin, thousands of meters above the earth. From there, a snowflake must navigate layers of differing temperature, pressure, and wind. It may pass through areas of rising warm air, updrafts, that carry it back upward for a moment, giving it more time to grow or cluster with other crystals. Then comes a downdraft, a stream of sinking cold air that tugs it downward again, gently or swiftly. If wind speeds increase, the flake begins to tumble, not violently, but softly, like a leaf turned over in a stream. Even its shape changes how it falls. Flat, plate-like snowflakes tend to flutter and glide like tiny parachutes. Columnar flakes or clusters may fall more quickly, twisting and bobbing. And large, complex dendrites often spiral gracefully, their branches catching air like delicate wings. In open fields, this dance of descent is visible, flakes swirling and zigzagging, never quite falling the same way twice. In forested places, the trees guide their paths, causing some flakes to hover in eddies of air, caught in miniature storms between branches. Even the warmth of your hand or glove, waiting below, plays a role. As the flake nears the surface, it may begin to change, partially melting, sticking to others, or catching the edge of a scarf or a sleeve. Its long journey ends not with a thud, but with a kiss of landing, and in its final moment, it carries a memory of wind. So the next time you look up into falling snow, know that each flake is in motion, not just down, but through and across and between. Everyone is a traveler, a wanderer, a soft explorer of air. And when it lands, it rests, having danced all the way down. In this chapter, we gently walk into the heart of a blizzard, where snowfall becomes a swirling veil, and visibility fades to just a few feet. A blizzard doesn't roar, it whispers, then swells, and before you know it, the world around you begins to blur, then fade, then disappear. Let's step gently into that swirling curtain, into a whiteout. Blizzards are storms of snow and wind, paired in just the right proportions to remake the world. Unlike calm snowfall, where flakes drift downward in silence, a blizzard sends snow sideways, upward, and around in circles. The air thickens, horizons vanish, the edges of buildings, trees, and roads dissolve into brightness. It feels as though the earth has been wrapped in cloud. But beneath this soft chaos, there is science, layers of temperature, wind, and pressure working in harmony to create something that feels almost dreamlike. Whiteouts begin when snow is lifted, not just from the sky, but from the ground. Strong winds, usually over 35 miles per hour, sweep across snow-covered landscapes, picking up loose crystals and carrying them into the air. The snow doesn't just fall, it flies. Fresh, powdery snow is especially prone to lifting. Each flake is light and dry, easily caught in gusts. And when visibility drops to less than a quarter mile, and the storm lasts for hours, we call it a full blizzard. But the sensation of a whiteout goes beyond visibility. It plays with orientation. In a full whiteout, there's no up or down, just motion and brightness. Shadows vanish. Light scatters in all directions, and depth disappears. You might stand still and feel as though you're drifting, even though your feet are on the ground. What causes this visual vanishing act? It's a trick of reflection and refraction. Snowflakes scatter light in every direction, bouncing and bending it through their crystalline structures. When millions of flakes move chaotically through air, light becomes unanchored. You can't tell where it's coming from, only that it surrounds you. Pressure systems give birth to these storms. Typically, a low pressure center pulls in moist air, while cold, dry air rushes in from behind. The meeting point between them becomes a zone of turbulence and lift. If the air is unstable, snow forms rapidly and winds intensify, stirring the flakes into flight. And yet, for all its motion, a whiteout is strangely silent. Sound is muffled, direction fades, even time seems to stretch, as if the storm is holding the world in pause. From inside a warm room, watching through a frosted window, a blizzard looks like a swirling ballet of light. From within it, it feels like being inside a snow globe, turned upside down and shaken. But even in this swirling world, there's a softness. No thunder, no violence, just air and ice, moving together. So let the whiteout carry you tonight, not with worry, but with wonder. Let your thoughts drift like snow lifted on wind. Let the world disappear for a while and become something bright and hushed and held. Beside cold lakes, winter storms intensify. Tonight, we journey to the quiet shores of deep inland lakes, not oceans, but great freshwater seas. Here, a unique kind of snowfall begins, not from faraway storms, but from the nearby water itself. This is lake effect snow, a wintry gift whispered across the shoreline. Imagine standing beside a vast lake in early winter. The air has turned cold, sharp and dry, but the water remains unfrozen, still holding warmth from autumn's end. As cold air sweeps over the surface, something magical begins. The lake breathes upward. Moisture, lifted by wind, rises from the water into the chill sky. As it climbs, it cools quickly, transforming invisible vapor into visible clouds. These clouds grow dense and full, their bellies heavy with snow. And as they drift toward shore, they begin to let it fall, flake after flake, in narrow, persistent bands. This is lake effect snow, born not in the heart of a storm system, but in the subtle difference between warm lake water and cold winter air. Wind direction is everything. If the wind blows long ways across the lake, from one end to the other, it gathers more moisture, more warmth. This is called the fetch. The distance air travels over water. A long fetch means a stronger snow band. By the time this air reaches land, it's carrying more snow than it appears capable of. And so, towns along the shore receive snow not from the sky's center, but from its edge. Snowfalls can be intense, yet strangely local. One neighborhood may see just a dusting, while another, only a few miles away, is buried beneath a foot or more. It's like a weather fingerprint, shaped by geography and motion. Elevation matters too. As snow-laden clouds move inland, they often rise slightly over hills or higher terrain. This lift helps squeeze out more moisture, causing flakes to fall faster and more heavily. It's called orographic enhancement, and it's one of nature's quiet ways of adding depth to snow. And sometimes, the snow doesn't stop. Lake effect events can last for hours or days, because as long as the lake remains unfrozen and the wind flows cold and steady, the snow continues, soft, persistent, and mesmerizing. These bands may stretch across open fields, over rooftops, into forests, painting everything in thick white. And because the flakes are often small and dry, the snow piles up like powdered sugar, drifting easily in the breeze. To watch it fall is to witness the lake speaking, breathing its warmth into the air, and the sky answering in snow. So, tonight, as you rest, picture a quiet lakeside village, sleeping beneath the gentle weight of an all-night snow. A gift, not from the storm, but from the lake. Not all snowfall is the same. Tonight, we'll drift gently through the many forms of winter's touch. Because, while we often call it all snow, the sky has many ways to send water downward. Each has its own journey, its own shape, its own quiet story. Let's begin with the simplest: snow grains. These are small, white, opaque particles, not fluffy like classic snowflakes, but more like tiny beads. They often fall from low grey clouds in cold, quiet conditions. They don't bounce, and they don't glitter. Instead, they feel soft underfoot, like dry sand lightly scattered by wind. Then there are ice crystals, minute, glittering flakes that sparkle in the air, especially in very cold climates. They can appear when the sky looks clear, floating gently like powdered stars. Often called diamond dust, they're not born from full clouds, but from the thin vapor near the ground on extremely cold days. Sleet is something different. It begins as snow, falling through a layer of warm air that melts it. But then, as it passes through another cold layer closer to the ground, it refreezes into tiny pellets of ice. These small balls click softly against windows and leave a delicate tinkling sound on rooftops. Sleet bounces. It has a presence you can hear. Freezing rain takes a different path. Here, snow melts completely into liquid raindrops as it falls through warm air. But if the surface below is below freezing, those droplets hit the ground and freeze instantly on contact. Trees become glassy. Power lines glisten. Roads turn to shimmering sheets. It's a quiet, beautiful hazard, silent and swift. And then there is graupel, soft white pellets that form when snowflakes collect supercooled water droplets during their descent. These droplets freeze onto the flake, rounding it out, softening its edges. Graupel looks like tiny balls of styrofoam and feels soft when touched. It's not hail, though it can look similar. Graupel is much lighter and often melts quickly. Of course, we mustn't forget the classic fluffy flurry, the kind we often picture. Light, feathery snowflakes floating in a dreamy drift. These form in cold, humid air and fall slowly, painting everything white with grace. Their structure is delicate, and they melt with the gentlest touch. Each of these forms is shaped by temperature layers in the sky. Imagine the atmosphere as a layered cake, each slice with its own warmth or chill. As snow falls, it travels through these layers, changing its state again and again. Some flakes melt, refreeze, gather, droplets, or remain unchanged. The final form we see, grain, pellet, drop, or flake, depends entirely on the sky's invisible arrangement. So next time winter reaches down from the clouds, pause and listen, not just with ears, but with attention. Ask yourself, what kind of snow is this? Because the sky speaks many dialects of winter, and each one, in its own way, is softly saying, I'm here. As we drift into Arctic air, we meet the polar vortex, a high-altitude whirlpool of cold that occasionally spills southward. Tonight, let's rise high above the world, beyond the snow, above the clouds, into the upper atmosphere, where winds don't just blow, they swirl in vast, icy loops. Here, in the stillness of the stratosphere, we meet the polar vortex. The name may sound dramatic, but the vortex is simply a vast, spinning river of cold air. It circles the poles all year long, moving quietly in the upper sky, far above the weather we see. During the colder months, it becomes stronger, tightening its spin, pulling icy air inward and holding it close. It's a kind of atmospheric boundary, a guardian of the Arctic's chill, but sometimes it wobbles. High-altitude winds, called the jet stream, help guide the vortex. When those winds weaken, often due to changes in temperature patterns or the warming of the stratosphere, the polar vortex can begin to stretch, shift, or split apart. It loses its tight spiral and spills. When this happens, fingers of cold air descend, reaching far into North America, Europe, or Asia. Cities that were mild one day may suddenly plunge into deep freeze. Skies clear, winds pick up, and temperatures drop sharply, sometimes by dozens of degrees. This event is known as a sudden stratospheric warming, a kind of domino effect in the upper atmosphere. When warmer air rises into the stratosphere, it disrupts the vortex from above, like ripples reaching the center of a calm pool. And when the polar vortex shifts, it doesn't bring snowstorms or loud weather. It brings stillness, sharp cold, a pause in the air, a kind of silence that feels deeper than usual. From above, these cold outbreaks look like tendrils of icy blue curling down from the Arctic like wisps of cloud. From below, they feel like a breath held too long, frosty and sudden. But the polar vortex isn't dangerous. It's not an invader. It's always there, circling, keeping the cold where it belongs. Only now and then does it wander. And when it does, the world below takes notice. Birdbaths freeze, rivers quiet. The edges of windows gather frost, and footsteps on snow sound sharper. It's as if the air itself becomes crystalline, still, fragile, and clear. In the quiet of these sudden freezes, we're reminded of how connected the layers of our sky truly are. That a ripple in the stratosphere, miles above our heads, can shape the feeling of a single morning. So, if you wake to sudden cold, a freeze that arrived overnight, quiet but certain, it may be the breath of the polar vortex reaching softly down, not to frighten, but simply to remind us that even the highest winds sometimes wander. Frost is the quiet painter of winter mornings. Before the world stirs, before the sun stretches its first rays across rooftops, frost arrives. It doesn't fall like snow or rain. It doesn't blow in with clouds or thunder. Instead, it simply appears, softly, silently, turning windows into lace, leaves into silver, and grass into glass. Tonight, we explore the artistry of frost. Frost forms when the air is cold and still, and moisture from the atmosphere meets a surface that's below freezing. But instead of condensing into liquid water, the vapor skips straight to solid, freezing instantly into delicate crystals. This process is called deposition. It's how invisible water becomes visible art. On clear, calm nights, especially after a day of lingering moisture, the ground cools rapidly. The absence of clouds lets heat escape into space, and surfaces like car hoods, rooftops, and blades of grass chill quickly. These cold surfaces invite moisture to settle and freeze. And from this quiet process, frost begins to bloom. Sometimes it appears as a light dusting, barely there, just enough to catch the moonlight. Other times, it grows in tall, feathery plumes. This is known as hoarfrost, a kind of icy fernwork that decorates branches, fences, and fields with silver-white lace. The name comes from an old word for grey-haired, because of the way it whitens the world, gently and with age-like grace. Each formation depends on humidity, wind, and temperature. Too much wind and the frost can't settle. Too little moisture and the crystals won't grow. But when the balance is right, when the air is moist and the night is calm, the frost becomes an artist. It paints in silence. No brush, no ink, just vapor, air, and time. On windows, it curls into patterns that mimic forests, rivers, and even feathers. Some believe these are echoes of the structure of ice crystals themselves. Tiny hexagonal lattices magnified across glass. Others say it's simply nature's improvisation, art born of stillness and cold. Frost is fleeting. The moment sunlight touches it, it begins to vanish. Like a whispered dream, it melts away before most of the world even notices. But if you rise early, if you wander into the dawn with quiet footsteps and open eyes, you might catch it. That gentle shimmer, that perfect, momentary stillness. A frost-covered world feels paused, as though the earth is holding its breath. Even birds move more slowly, their feathers puffed against the chill, and every surface glows, softly, delicately, like it's been touched by something kind. So if morning comes and your window holds a frost-drawn forest, pause for a moment. Let yourself wonder. Let yourself rest in the hush, because frost is more than cold. It's a winter lullaby, written in crystal and light. Travel through history's snowiest days. Tonight, let's drift softly through memory, through weather maps and whispered legends of winter's deepest moments. This is not a tale of chaos or crisis, but of awe, of how the sky, when given time and terrain, can lay down blankets so thick, so deep, they become part of history. Snow has always fallen, but sometimes it falls with such patience, such abundance, that we measure it not in inches, but in feet. And we remember, our journey begins high in the mountains, where air rises, cools, and condenses with ease. Mount Rainier in Washington State is one such place. It receives extraordinary snowfall thanks to its elevation and exposure to moist Pacific air. In the winter of 1971 to 72, the mountain's Paradise Ranger Station recorded more than 1,100 inches, over 90 feet, of snow. Imagine a winter so full, so unhurried, that it built a wall of snow taller than trees. But it's not just mountains that receive these generous gifts. In Tamarack, California, in 1911, nearly 400 inches fell in a single season, an early record that still stands, soft and towering in time. These numbers are made possible by something called atmospheric rivers, long plumes of moisture that stream in from ocean to land. When they meet cold air and elevation, they unload their snow slowly, steadily, completely. Sometimes it's not just the volume of snow, but the speed at which it falls. In Silver Lake, Colorado, in April 1921, over 75 inches fell in just 24 hours. That's more than 6 feet in a single day. A mountain storm stalled, spinning snow in place, hour after hour, until the world outside was nearly unrecognizable. But even outside the mountains, snow has surprised us. In Watertown, New York, and other communities along the Great Lakes, lake effect snow has delivered extraordinary totals. A single snow band, fed by open water and cold winds, can remain parked over one location, snowing for days without pause. Sidewalks disappear, houses look buried, streets transform into frozen rivers. And yet, in all of this, there's silence, because snow does not fall in anger, it falls in patience. Whether it comes from stalled low-pressure systems, trapped between pressure ridges, or from a nor'easter spinning its story along the coast, or from a quiet, persistent flurry that simply never ends. Each flake adds to a growing blanket, layer by layer, hour by hour, and underneath it all, the world slows down, doors stay closed, fireplaces crackle, and the snow becomes part of our stories. Children dig tunnels through drifts, neighbors share shovels and cocoa, and long after the snow has melted, people still speak of that winter, the big one, the one where the sky wouldn't stop. So tonight, let's remember those deep winter blankets, not as burdens, but as quiet records of nature's generosity, soft weight, measured in time and stillness, written in inches, remembered in feet. Icicles are frozen time. They hang from rooftops, railings, tree branches, glassy curved, and crystalline. Tonight, let's slow down enough to see what they truly are, the frozen poetry of melt and cold. An icicle begins with warmth, a little sunlight, a gentle thaw. Snow on a rooftop or slope begins to melt, forming droplets that creep downward, guided by gravity, shaped by edges and eaves. As the drop reaches the colder air near the edge of a roof or railing, it cools again. Just before it falls, the outer layer begins to freeze. And with each new drop that follows, melting, trickling, freezing, a slender spear begins to grow. This is refreezing in motion, a sculpture built not by hands, but by timing. Temperature gradients are key. The rooftop must be warm enough to melt snow during the day, but the air beneath it, especially near the edge, must remain below freezing. This contrast allows for continuous drip and freeze, a perfect rhythm of meltwater and cold. The speed of growth depends on the drip rate. Too slow, and the icicle barely forms. Too fast, and the water runs off before freezing. But just the right pace allows the icicle to lengthen steadily, sometimes by mere millimeters per hour. Shade plays a role too. Icicles that grow on the north side of buildings, or in the shadows of trees, often last longer and grow more dramatically. In shaded spots, the freeze happens more quickly. Less sun means slower melting, but also less evaporation, preserving each droplet long enough to join the sculpture. Over time, icicles can reach extraordinary lengths. Some curl at their tips, some grow straight like frozen stalactites, some form in clusters like frozen chandeliers. Inside, a complex structure is forming. Water molecules align into hexagonal crystals, just like in snowflakes, but stretched by flow and pulled by gravity. And though they may look solid, icicles are always in motion. Not fast, not visible, but molecular. Layer by layer, they shift, responding to wind, temperature, and even the salt or dust in the meltwater. This is why no two icicles are exactly alike. Some are clear and smooth, others cloudy and textured. Some taper elegantly, others are bumpy or twisted. Each one carries the fingerprint of the weather that made it, and when sunlight passes through them, they glow, turning porches and gutters into galleries, casting refracted light onto snow below. Eventually, all icicles melt, either slowly under the gentleness of a warming day, or quickly, breaking loose and falling with a final soft crack. But while they last, they hold something beautiful, a record of temperature, a sketch of time, a crystal made from patience. So next time you see one hanging silently, let it remind you. Even the smallest changes, sunlight, shade, a drop of meltwater, can build something lasting. Frozen time, in the shape of a quiet spear. Nor'easters arrive with wind, snow, and heavy skies. Tonight, we follow the hush before a storm, down the Atlantic coastline, where cold air lingers inland, and the ocean breathes out warmth. Here, in this meeting of chill and moisture, a powerful winter visitor forms, the nor'easter. Its name comes from the direction of the wind, northeast, gusting ashore as the storm turns counterclockwise along the coast. But a nor'easter is more than wind. It's a wintertime symphony of snow, low pressure, and swirling cloud. These storms are born along the Gulf Stream, where warmer waters flow just off the eastern US shoreline. When Arctic air slides southward over land and meets this moist Atlantic air, the temperature contrast becomes a kind of fuel. It sets the stage for a mid-latitude cyclone, which begins to spin, slowly at first, then tighter, deeper, stronger. As the low-pressure system deepens, it draws in moisture from the ocean and cold from the continent. The storm wraps itself into a spiral, cloud bands circling inward, the air spinning faster, the snow beginning to fall. And when conditions are just right, the nor'easter stalls. It pauses along the coast, barely moving, releasing snow for hours, or even days. These are the snow-laden cyclones that paint entire cities, white, quiet highways, and deepen winter's breath. Famous nor'easters have left their mark on weather lore. The blizzard of 1996, which buried parts of the mid-Atlantic in over 2 feet of snow. The February superstorm of 2013, which shut down roads and trains across the northeast. And the unforgettable storm of the century in 1993, so powerful it spanned from the Gulf of Mexico to eastern Canada, touching nearly every part of the eastern US. Despite their scale, nor'easters often begin humbly. A ripple in the jet stream, a dip in pressure, a quiet swirl off the Carolinas. And slowly, as if stirred by the hand of winter itself, they strengthen. Along the coast, winds pick up, blowing snow sideways, rattling shutters, curling snow into drifts. Inland, the air grows colder and drier, helping the snow fluff and accumulate. At the storm's center, pressure continues to fall, a meteorological heartbeat, slowing the storm's forward movement. And then, for a time, the world disappears beneath white. Nor'easters can bring thundersnow, coastal flooding, and snow measured not just in inches, but in stories told for years to come. But inside, behind windows, there's warmth. Fires crackle, kettles hiss, and the snow taps gently on the glass. Even at their most intense, nor'easters are wrapped in softness. Their power, while great, is expressed in snowflakes, not shouts. In wind that sculpts snowbanks, not fear. So tonight, let's imagine the storm not as a threat, but as a storyteller, a winter poet sweeping up the coast, leaving white verses behind in every town it visits. In this chapter, we explore the slippery science of freezing rain. Sometimes, the sky weeps not in flakes, but in drops, clear, glassy, and silent. And when those drops fall through layers of cold, the world below begins to shine. This is the soft mystery of freezing rain, a winter phenomenon that turns landscapes into crystal. Let's begin in the clouds. High above, snowflakes form in cold air, just like always. But as they fall, they pass through a warm layer in the atmosphere, a band of air just above freezing. Here, the flakes melt into raindrops, and then, just before they reach the ground, they enter another layer, sub-freezing air, cold but shallow, not long enough to refreeze the droplets mid-air, but just long enough to chill them. So, the raindrops reach the surface still liquid, supercooled, yet ready to freeze. The moment they touch anything below freezing, branches, railings, roads, even blades of grass, they crystallize instantly, not with sound or flash, but with a silent, spreading sheen. The result is breathtaking. Trees become chandeliers, each branch wrapped in ice. Power lines sag under the weight of glassy coats. Sidewalks vanish beneath invisible layers of slipperiness, and rooftops shimmer like mirrors. Freezing rain doesn't build upward like snow. It builds around, encasing surfaces in smooth shells. A twig becomes a prism, a fence post, a sculpture. Even the smallest leaf can hold a world of ice. Meteorologists call this an ice storm when the buildup exceeds a quarter inch. But the term belies its beauty. These storms are quiet. There's no howl, no roar, only the occasional crack of a branch giving way under icy weight, or the soft tap of rain that feels like sleet, but isn't. Walking through a freshly iced landscape is like stepping into another world. Sound is muted, colours are pale, and everywhere there's reflection, light caught and held in glass. Stillness dominates, because freezing rain, despite its calm, changes everything. Travel slows, footsteps are careful, and those who venture out move as though the world itself is fragile. Even birds seem to pause, waiting for the thaw. But like all of winter's art, it is temporary. As temperatures rise, the ice melts in soft drips. Droplets fall from eaves and branches like glass tears. The shine dulls, the glaze fades, and the world re-emerges, wet but unharmed. Still, the memory of the freeze lingers. So tonight, if the world around you has turned to crystal, or if you simply imagine it so, let yourself be still with it. Admire the glaze, the shimmer, the soft quiet that freezing rain brings. A moment suspended, a breath held in ice. And remember, even the slipperiest storms can be beautiful. Snow doesn't just fall, it moves. Tonight, we follow the wind, not in its roar, but in its whisper. We follow it across open fields and winding roads, where it carries snow not down, but across. This is the story of snowdrifts, the quiet sculptures that wind calves from air and crystal. When snowflakes fall, they don't always stay where they land, especially when the snow is dry and powdery, light as dust, weightless as breath. In the presence of wind, these flakes take flight once more, skimming along the surface like grains of sand in a desert breeze. And just like sand, snow gathers. It begins with a breeze. Even a gentle wind, 10 to 15 miles per hour, is enough to set loose snow in motion. The flakes begin to saltate, hopping and bouncing low to the ground. As the wind strengthens, the snow rises, swirls, and finally flows in rolling waves, fluid, soft, and bright. The landscape becomes a canvas, and the wind an unseen sculptor. Snow is deposited in uneven layers. It gathers behind fences, buildings, tree lines, any place where the wind slows, even for a moment. These barriers disrupt the wind's energy, causing it to drop some of the snow it carries. The result is a drift, a mound of snow built not by falling flakes, but by wind-borne ones. Drifts often take on graceful forms, rippled, layered, even hollow. They can mimic the curves of sand dunes or ocean waves, shaped by the steady rhythm of air. Some rise into long, gentle ridges along the ground. Others form sharp crests and smooth valleys, like miniature mountain ranges. The texture of the snow matters. Light, dry snow is easily lifted and sculpted. Wet snow, heavy with moisture, tends to stay where it falls. That's why drifts are most common after storms with cold, powdery snowfall, and especially when winds follow quickly behind. Open terrain plays a role as well. Flat fields, prairies, and plains offer little resistance to wind. Here, snow can travel great distances before it finds a resting place. It might start as a storm in the mountains, but end up in a drift hundreds of miles away, shaped by a journey of air. In towns and along roads, snow drifts form in the wake of buildings and cars, tucked into corners, pressed against doors, curled around lampposts like sleeping cats. Sometimes, drifts are playful, small ridges you step over or hop across. Other times, they grow large enough to bury fences or block highways, sculpted overnight into silent white walls. Despite their quietness, drifts are dynamic. They shift with each gust, change shape with every breeze. And when sunlight hits their ridges at just the right angle, they glow, revealing intricate patterns, delicate ridges, and soft shadows. To walk through a snowy landscape shaped by wind is to move through a gallery of natural art. No artist planned these forms. No hand placed the snow. Only air and time. So, if you find yourself near a drift, whether it's knee-high or towering, pause for a moment. Let your hand brush its side. Feel its surface, sometimes firm, sometimes feathery. Listen to the quiet it holds. Because each snowdrift is a memory of motion, a sculpture of wind shaped without sound. Where does the cold come from? Tonight, we follow the breath of winter. Not the snow or wind, but the very air that carries the season in its lungs. We drift with the great Arctic air masses, slow, sweeping bodies of cold that signal the true arrival of winter. High above the polar regions, the atmosphere is calm, clear, and deeply cold. Here, air pools quietly, untouched by storms, resting over ice and tundra. This air is dense, dry, and stable, cooled over days and weeks of long Arctic night. It forms what meteorologists call a continental polar or Arctic air mass, a dome of cold that sits in stillness until nudged. And when that nudge comes, often from a shift in the jet stream or a passing low-pressure system, the cold begins to move. It doesn't rush, it glides. Arctic air advances slowly, methodically, like a glacier in motion, or a tide rising across a continent. Its front is often sharp. One moment, the air is crisp and autumnal. The next, breath turns visible and ponds freeze over in silence. As the cold air moves southward, it hugs the surface, heavy and unmoving. Because it is denser than the warmer air ahead, it undercuts it, creating a subtle but powerful wedge. Clouds often form above this boundary, but the Arctic air below remains clear, still and blue beneath winter sun. Unlike humid tropical air, Arctic air is dry. It brings clear skies, deep chills, and hard frosts. Snow squeaks underfoot. Breath fogs instantly, and the cold feels sharper, cut from ice, not water. This dryness allows for rapid cooling at night. Without clouds to trap warmth, heat escapes easily into space, and temperatures can plummet. It's not uncommon for Arctic air masses to bring sub-zero temperatures even to southern regions, far from their point of origin. And yet, for all their force, these air masses are peaceful. There is no thunder in their arrival, no lightning, just a deepening, quiet, a kind of atmospheric exhale. We often talk about cold fronts, but Arctic air doesn't behave like a storm. It settles. It lays across the land like a wool blanket dipped in frost. It's the breath of the north, travelling southward with ancient patience. Over time, the air mass moderates. It picks up moisture. It warms slightly. But in its core, the Arctic chill lingers, waiting to remind the Earth of winter's presence. These air masses set the stage for snowfall, for frost, for the long, still nights of winter. So, if you feel the cold arriving, not as a gust, but as a change in the very air you breathe, know that you are standing in the path of something vast, something that began thousands of miles away, over ice and tundra, and found its way to your doorstep, quietly. Arctic air moves without haste. It doesn't need to rush. Winter, after all, always arrives on time. Some winter storms arrive like whispers. Others come in sudden bursts. Tonight, we step into a different kind of snowfall. Not the gentle, drifting kind, but something sharper, fleeting, fierce, and then gone. This is the world of snow squalls, short-lived storms that arrive with little warning, changing the sky in moments, then vanishing just as fast. To understand a snow squall, we must first understand contrast. Warmth meeting cold. moisture meeting dry, stillness meeting motion. A snow squall forms when a sharp front, usually a cold front, pushes into a region of unstable air. Cold, dry air rushes in from behind, sliding under warmer, moist air at the surface. That warmer air is forced to rise quickly, cooling as it lifts. And as it cools, clouds bloom, fast and dark, filling with snow. Within minutes, what was a calm, bright winter day can turn white with movement. Winds pick up suddenly. Snow begins to fall, not gently, but in quick, stinging flurries. The sky darkens. Visibility drops. If you're on the road when a squall arrives, you might feel as though the world disappears. Headlights glow softly through a wall of snow. Trees vanish into the white. Even nearby houses can fade from view. But unlike a full-blown snowstorm, a snow squall is brief. Most squalls last just 30 minutes or less. Some pass over in 10. They move quickly, riding fast-moving fronts, sweeping through towns, and then continuing on their way. Because of this, they're often described as microbursts of winter, pockets of intense snowfall and wind wrapped into a small space and time. The snow they drop is usually dry and powdery, perfect for drifting and blowing, especially when wind speeds rise. And because of the sudden drop in visibility, snow squalls can be deceptively dangerous, especially for drivers. But inside a home, a snow squall feels like a momentary winter rush. The windows rattle. The view outside turns to static. Then, quiet. Blue sky again. They're most common in regions that experience frequent cold frontal passages, such as the Great Lakes or northern plains. But squalls can happen anywhere the contrast is sharp enough, where cold air pushes fast and hard into moist, warmer air. Sometimes, snow squalls are accompanied by thunder, what we call thunder snow, a rare and dramatic phenomenon where lightning flashes behind falling flakes. Even so, the overall nature of a snow squall is more about swiftness than sound. To meteorologists, snow squalls are defined by sudden drops in visibility, wind gusts over 25 miles per hour, and short durations. To the rest of us, they are simply surprises, quick storms that demand our attention, then disappear before we can process them, like a page briefly turned by the wind. So tonight, if you imagine a snow squall, picture the sky as a curtain, suddenly drawn closed, then opened again, a fleeting burst of winter, gone before the snow has even settled. Wind can make cold feel colder. Not all cold is the same. Some cold is still and silent, like the air inside a snow globe. Other cold is moving, wrapping around you, pulling at sleeves and cheeks and fingers. Tonight, we explore the chill of wind, the way moving air can make even mild cold feel deeper, sharper, more present. This is the quiet science of wind chill. Your body, even in cold weather, gives off warmth. A thin layer of warm air clings close to your skin, like an invisible barrier. It's this small buffer that helps you feel stable, even when temperatures drop. But when the wind begins to blow, it brushes that layer away. Not all at once, but constantly, replacing it with colder, faster air. The result is more rapid heat loss from your skin. You feel colder, not because the air temperature has changed, but because the wind has stripped away your warmth. This is why a breezy 25 degrees Fahrenheit day feels much colder than a still 25 degrees Fahrenheit day, and why, sometimes, a calm 15 degrees Fahrenheit can feel gentler than a gusty 30 degrees Fahrenheit. Meteorologists calculate wind chill by combining actual temperature with wind speed, using a formula that estimates how quickly the skin loses heat. The result is a wind chill temperature, what the cold feels like on exposed skin. For example, if it's 20 degrees Fahrenheit with a light wind, the wind chill might be 15 degrees Fahrenheit. If the wind picks up to 25 miles per hour, the wind chill could drop to 5 degrees Fahrenheit, or even lower. It's important to note, wind chill doesn't affect objects, only living things. A car doesn't freeze faster in high wind, and a tree doesn't feel colder. But for people, animals, and any warm-blooded creature, wind chill is real and very tangible. Even a mild winter day can feel biting with enough wind. That's why scarves, hoods, and windproof layers help so much. They don't just insulate, they protect that fragile layer of warm air your body creates. In the open tundra, where wind is constant, wind chill can drop dangerously low. But even in suburban neighborhoods, walking against the wind can feel like stepping into a colder season entirely. Still, wind is not always unwelcome. It brings movement to the cold. It shapes snowdrifts, sends leaves scuttling across sidewalks, and carries the scent of distant fireplaces. Wind gives winter its texture. Without it, the season would feel flatter, quieter, less alive. Wind chill reminds us that cold is not just a number. It's an experience, a moment shaped by motion. So next time you step outside and feel the wind nip at your fingers, imagine the science happening around you. Invisible heat lifting from your skin, carried away on currents. Your body gently negotiating with the weather. And then step back inside. Let the stillness warm you again, because sometimes all it takes to feel better is a little less wind. Sometimes in winter, warm air floats above cold ground, sealing everything beneath it. Tonight, we enter a quiet stillness, not the hush of snowfall, nor the silence of frost, but a different kind of pause in the atmosphere. This is the world of temperature inversions, when the air flips its script, when warm floats above cold, and the earth holds its breath. Normally, in the lower layers of our atmosphere, air gets colder the higher you go. Warm air near the surface rises, carrying moisture and pollutants upward. Cooler, denser air stays above, and the atmosphere moves in gentle convection, up and down like a slow breath. But sometimes, especially on calm winter nights, this order reverses. A temperature inversion forms when a layer of warm air settles over colder air near the ground. The surface, cooled overnight, chills the air just above it. Meanwhile, the upper air, warmed by a setting sun, a passing front, or lingering warmth from above, remains slightly warmer. This creates a cap, a lid on the lower atmosphere. Instead of rising, the cold air near the ground becomes trapped, and with it, so does everything it holds: fog, frost, smoke, even pollutants. The result is a frozen bowl of air, quiet, unmoving, perfectly still. These inversions are most common in valleys, where cold air can slide down hillsides and settle like water. The surrounding ridges act like the rim of a bowl, holding the cold in place. In cities, this can lead to smog, a grey haze that lingers, especially when there's no wind. In rural areas, it might mean dense fog, curling along roadways and over snowy fields. The sky above remains clear and bright, while the world below sits beneath a veil. This contrast can be striking. From a nearby hilltop, you might see a sunlit landscape, while the valley below looks cloaked in grey. Inversions also amplify cold. Because the trapped layer of air can't rise or mix, it continues to cool overnight. Frost thickens, pipes freeze, the cold deepens, and without wind, the stillness becomes profound. Sounds travel farther. Smoke rises, then flattens. The air feels heavier, closer. To break an inversion, the sun must warm the surface enough to stir motion again, or a front must move through, bringing wind to lift and mix the layers. Until then, the world remains paused, frozen in place, quiet, layered, still. Temperature inversions are gentle phenomena. No lightning, no thunder, no gusts. Just air rearranged. Warm above, cold below. So, if you wake to fog that doesn't lift, or a world that feels held in place, you may be standing in a hidden valley of weather, wrapped in a winter inversion. And within that quiet bowl, time seems to slow. What creates the perfect snow day? For many, a snow day is magic, a day of softness, of stillness, of waking to find the world transformed and the clock mercifully quiet. Tonight, we look behind the scenes, into the skies, the maps, the patterns. What meteorological recipe must come together to create that most welcome of winter mornings? It starts with cold air at the surface. Temperatures near or below freezing are essential, cold enough for snow to fall and stay. But that's just the beginning. Next, we need moisture. Often, it's carried by a low pressure system, spinning slowly, pulling air in from the south or east. This moist air rides over the colder air already in place, forming clouds thick with snow. The snowflakes begin high, as crystals in frigid clouds. They fall through layers of cold and colder still, keeping their shape all the way down. The best snow days often happen at the meeting point of warm and cold, where fronts collide, but gently. Here, flakes fall steadily for hours, not in a blizzard, not in a squall, but in that perfect, dreamy rhythm of accumulation. Timing plays a role too. Snow that begins overnight is more likely to delay a school morning or quiet a city commute. The roads become soft and white, untouched by tires or salt. Forecasters look for clues. Snowfall rates above 1 inch per hour. Long duration events. Cold ground that lets snow stick immediately. They watch radar screens like storytellers, predicting whether the morning will be blanketed or bare. In some regions, lake effect snow can surprise even the forecasters, dropping a foot of snow on one town while another remains dry. In others, upslope flow brings snow to mountain towns from hidden pockets of wind. But whatever the origin, a snow day is more than meteorology. It's a feeling, a quiet awakening, the creak of floorboards, the glow of grey sky, and the sound of nothing, no buses, no alarms, just the hush of snow. Children press faces to windows, coffee brews slowly, and the world moves at half speed, wrapped in white. Even adults pause, just a little longer, over breakfast or books or blankets, because snow days offer something rare, permission to rest, all because the atmosphere aligned, a touch of cold, a touch of moisture, and just enough time. So tonight, drift to sleep under the possibility of flurries. Let your dreams curl like snowflakes, and know that sometimes the sky rearranges itself, not for danger, but for wonder. Glistening branches, glimmering roads. Tonight, we walk through a world transformed, where trees shimmer as if made of glass, and rooftops wear coats of crystal. This is the haunting beauty and quiet danger of the ice storm. Unlike snow or sleet, an ice storm begins in layers. Up high, in the clouds, snowflakes form as usual, crystalline, delicate, full of frozen geometry. But as they fall, they meet a pocket of warm air, just warm enough to melt them into raindrops. Now liquid, the rain continues to fall. But before it reaches the ground, It passes through a second layer, a shallow zone of freezing air, hugging the Earth. This cold air isn't deep enough to refreeze the drops into sleet. Instead, they stay liquid, but only just. We call this supercooled rain, water that's below freezing, but still liquid, suspended in a delicate state of instability. And the moment it touches something, anything, below 32 degrees Fahrenheit, it freezes on contact. A branch, a sidewalk, a power line. The transformation is instant. A thin film of ice spreads like glass across every surface it touches. Drop by drop, the world becomes encased. This is the crystal cloak of an ice storm. It doesn't pile like snow. It builds around, wrapping each twig, each wire, each blade of grass in a transparent glaze. At first, it's mesmerizing. Street lamps glow against icicled trees. Car roofs gleam like mirrors. And in the stillness, the world seems to pause. Frozen, not just in temperature, but in time. But slowly, the weight builds. Ice is heavy, far heavier than snow. Just a quarter-inch of accumulation can add hundreds of pounds to a single tree. Branches bend, then snap. Power lines bow low. The soundscape changes, from silence to a soft, brittle cracking. The occasional crash of ice-laden limbs falling to the ground. It's a gentle kind of danger. Ice storms rarely arrive with wind or thunder. There is no warning roar, only the hush of freezing rain tapping at windows, and the world slowly stiffening under its touch. Meteorologists look for signs. A layer cake of temperature readings, a warm layer aloft, a shallow freeze below. Forecasting an ice storm requires reading between the layers, watching not just the temperature on the ground, but miles above it. And the timing matters. An early winter ice storm may glaze fallen leaves, turning them slick and treacherous. A late season storm might freeze atop melting snow, trapping moisture beneath a glassy seal. But in every case, it's a story of imbalance, of warm and cold colliding, but not mixing, of water caught between states, of stillness meeting motion and turning to crystal. When the storm ends, the thaw begins, slow, steady, drips echo from icicles. The shimmer dulls, the cloak melts, but for a while the world held its breath beneath glass, and it was beautiful. So, if you ever wake to find the trees glistening, the ground shining, and the air cold but calm, you may be standing inside the memory of an ice storm, a delicate equilibrium, briefly held. Even in the cold, moisture matters. We often think of winter as dry, crackling, bitter, still, but hidden in the chill, humidity lingers. And tonight, we explore how moisture shapes the texture of snow, the weight of the air, and the very feeling of a winter's day. Humidity is simply water in the air, invisible but present. And even when temperatures fall below freezing, that water doesn't vanish. It changes form and changes everything. In dry winter air, snow becomes powder. Each flake remains light, separate, and crisp. You can brush it off a coat or fence post with ease. It squeaks underfoot. It swirls in wind like dust. This is the snow of alpine slopes, of snowdrifts, of soft silence. But when humidity rises, snow becomes heavier. Flakes stick together, clumping into wet snow. Denser, damper, ready for packing into snowballs or snowmen. Wet snow sticks to branches, to mittens, to the sloped roofs of cottages. It falls more slowly, more gracefully, in large, fluffy clumps that seem to float. It's the kind of snow that clings and quiets the world even more. Humidity also shapes fog in winter, when cold air settles over moist ground, or when warmer, humid air flows over snow-covered surfaces. Fog forms, a low, drifting mist that softens the horizon and mutes the morning. Fog in winter doesn't rise in plumes. It curls and rests. It's made not of smoke, but of countless suspended droplets, hanging in cold stillness. Even indoors, humidity plays a role. When outdoor air is very dry, and we bring it into warm homes, the relative humidity plummets. Your skin may feel tight, your lips cracked, wooden furniture creaks, static electricity snaps with a whisper. Many notice that indoor air feels different when snow is falling. Why? Because snow adds moisture. As flakes fall and melt, they release a subtle softness into the atmosphere. A snowstorm can raise indoor humidity just slightly, enough to be felt. It's one reason snow days feel cozier, fuller, more restful. Humidity also shapes how cold feels. In dry cold, the air bites cleanly. In humid cold, it clings. That's why a damp 35 degrees Fahrenheit day can feel more chilling than a crisp 25 degrees Fahrenheit day. And humidity influences frost and ice crystal formation. The more moisture present, the more intricate the frost, the more delicate the lace drawn across windows. So, even in winter, where ice rains and snow gathers, water is still in motion, floating, hiding, shaping, not in splashes or puddles, but in the weight of a snowball, the curl of morning fog, the glimmer of hoarfrost. Moisture makes the cold come alive. So the next time you breathe out into winter's air and watch your breath drift upward in a pale cloud, remember, even in the freeze, there is softness. Snow is more than weather. It's a planetary mirror. Tonight, we rise above the clouds, beyond rooftops, beyond forests, even beyond the mountains, until we look down at the world dressed in white. It's winter, and snow covers stretches across continents. From Arctic tundra to alpine slopes, the earth gleams with brightness. But this isn't just scenery, this is science. Snow is part of Earth's quiet, powerful balancing act. Snow doesn't just fall, it reflects, and in doing so, it helps regulate the planet's energy balance. This reflective quality has a name: albedo. Albedo measures how much sunlight a surface bounces back into space. Fresh snow has one of the highest albedos of any natural surface, reflecting up to 90% of incoming sunlight. By contrast, darker surfaces, like forests, oceans, or bare soil, absorb much more heat. When snow blankets the ground, it becomes a mirror for the sun. Instead of soaking in warmth, the planet reflects it outward, staying cooler beneath the white. In this way, snow acts like a shield, gently resisting the warming of the Earth. This becomes especially important in the polar regions, where snow and sea ice stretch for hundreds of miles. Here, reflective surfaces help keep Arctic and Antarctic temperatures low, creating a feedback loop that maintains their chill. But this loop is fragile. When snow cover melts, whether from a warm spell, a shifting climate, or seasonal change, the exposed ground beneath is darker, and that dark surface absorbs more heat. This melts more snow, which in turn exposes more dark ground, and the cycle continues. This is called a positive feedback loop, though it's not always positive in effect. It means that a small change, like melting snow, leads to a bigger one: increased warming. Snow slows this process. It buys time, it reflects light, and offers coolness. And while it doesn't stop global warming, it adds a soft resistance, a whisper of equilibrium. Snow cover also affects air temperatures. A snowy field, reflecting sunlight, won't heat up as quickly as a bare one. That keeps the air just above it cooler. Cities surrounded by snow may experience colder daytime highs and longer-lasting chill. Snow even affects plant and animal life through this energy balance. Some creatures rely on snow's insulation. Yes, insulation. Because while snow reflects heat above, it also traps warmth below. A thick snowpack can keep the soil beneath several degrees warmer than the air above, protecting roots, seeds, and hibernating animals. From satellites, scientists monitor snow cover every day. They measure its extent, its depth, and its brightness. These values go into climate models and seasonal forecasts. Because snow, though temporary, tells us something about the Earth's mood, how it is breathing, how it is changing. And so, as you gaze out at a snowy landscape, or even dream of one while tucked beneath warm blankets, know that you're imagining something bigger than weather. You're imagining part of the planet's soft defense, a white breath that cools the surface, a moment of pause in the warming rhythm of the world. Snow is not forever, but while it stays, it reflects and reminds us that even silence can have strength. Jet streams guide the weather. Tonight, we ride the wind, not the breezes near the surface, nor the gusts between trees, but the rivers of air high above, where planes fly and clouds stretch thin. These are the jet streams, invisible, fast, and profoundly important. Jet streams are narrow bands of strong wind in the upper levels of the atmosphere, flowing from west to east. They form at the boundaries between warm and cold air masses, acting like walls or bridges between seasons. In winter, they become powerful architects of our weather. There are two major jet streams that matter most: the polar jet stream and the subtropical jet stream. The polar jet forms where cold Arctic air meets milder mid-latitude air. In the winter months, as that Arctic air expands, the polar jet strengthens, often dipping farther south, bringing with it the chill of the north. The subtropical jet, by contrast, flows higher and farther south. It carries moisture from oceans and warm lands, sometimes merging with the polar jet to create massive winter storms. But what makes these streams so fast? It's all about contrast. The sharper the temperature difference between two air masses, the faster the air flows between them. In winter, these differences are more extreme, so the jet streams speed up. Jet streams can flow at over 200 miles per hour, but not in straight lines. They ripple, they bend, they meander. These bends are called ridges and troughs. A ridge pushes warm air northward. A trough pulls cold air southward. And it's in these curves that weather happens. When the jet stream dives into a deep trough, it can drag Arctic air far into lower latitudes, bringing sudden freezes, snowstorms, and crisp blue skies. When it lifts into a ridge, mild air flows northward, sometimes causing winter thaws or rainy days in place of snow. Storms often form along these boundaries, guided by the jet's momentum. Low pressure systems ride along the jet like surfers on a wave, growing stronger as they spin beneath the swift winds above. Meteorologists watch the jet stream closely. Its movements help predict cold spells, snow chances, and even the arrival of nor'easters or blizzards. But the jet stream doesn't make noise. You can't feel it brushing your cheek. It's silent, high, constant. It moves miles above your head, and yet it shapes what you feel each day. The warmth in the wind, the sharpness of a cold front, the slow spin of a snowstorm. Climate scientists are also studying how the jet stream may shift as the planet warms. Some evidence suggests it may become slower and more wobbly, leading to longer cold spells or lingering weather patterns. But tonight, let's simply marvel at its presence. The sky, flowing in fast rivers, invisible paths of motion, guiding clouds and chill, patterns etched in wind. So, as you rest beneath the stillness of your ceiling, remember that miles above, the air is racing, not in chaos, but in graceful, curving streams. And from that height, winter is written in motion. While low pressure brings stormy drama, high pressure brings winter stillness. Tonight, we rise gently, not into a storm, not into swirling clouds or rushing winds, but into calm. This is the realm of the high pressure system, a wide, invisible dome that settles over the land and sky like a soft, cold lid. It doesn't bring drama, it brings clarity. In the center of a high pressure system, air moves downward, unlike low pressure, where air rises, forming clouds and storms. High pressure systems push air down toward the earth, and as it sinks, it dries. Clouds fade, skies clear, and the wind slows to almost nothing. We call this subsidence, a gentle sinking of air. And though it sounds simple, its effects shape some of the coldest, clearest nights of winter. With no clouds to trap heat, warmth escapes from the ground, like a soft exhale into the upper atmosphere. This is called radiative cooling, a slow, steady loss of warmth into the stars. Snow-covered ground enhances the effect. Bright and reflective, snow bounces sunlight away during the day, and loses heat quickly at night. When a high-pressure system settles in, the result is a perfect recipe for cold, stillness, clear skies, and a long, uninterrupted night. These are the nights when frost creeps quietly across windows, when ponds freeze over, when the world feels paused. High-pressure systems can linger for days or even weeks, and the longer they stay, the more settled everything becomes. You may notice that sounds seem sharper. A distant train whistle, the crunch of footsteps in snow. With no wind and a little atmospheric movement, sound travels farther, carried gently across frozen fields. In valleys and basins, high-pressure systems can trap cold air like a bowl. This creates temperature inversions, where cold, dense air sits near the ground, and warmer air rests above. The result is fog, frost, or layers of ice crystals suspended in the still air, glowing under streetlights. But high pressure doesn't always mean comfort. In dry regions, it can bring prolonged cold snaps or poor air quality. Without wind or rising motion, pollutants and smoke can accumulate near the surface, creating hazy days beneath a bright blue sky. Still, there's something peaceful about high pressure. No rushing clouds, no thunder or snow squalls, just the steady, slow presence of stability. Meteorologists recognize high-pressure systems by the blue H on weather maps, but their real signature is in the quiet, the way your breath fogs in the morning stillness, the long, low shadows cast by a winter sun, the untouched surface of a frozen pond. So tonight, imagine lying beneath that great dome of calm, stars above, snow below, the air unmoving, the sky wide and clear. No need for words, no need for movement, just winter's hush, held in the hands of high pressure. We glide over mountain ranges where one side receives heavy snowfall, while the other lies dry and bare. Mountains divide the land, and they also divide the weather. Tonight, we float above ridgelines and snowy peaks, watching the way the sky behaves as it brushes against stone. This is the story of orographic lift and the silent shadows it leaves behind. As moist air moves across the land, it sometimes encounters a mountain range in its path. It cannot go through the mountain, so it rises. Up the windward side, the air climbs, lifted higher by the terrain, cooling with every step upward. This cooling happens because as air rises, it expands, its pressure drops, and its temperature falls. We call this adiabatic cooling, and as the air cools, its moisture condenses. Clouds form, snow begins to fall, and the windward slopes, those facing into the incoming air, become draped in white. This is why mountain towns on the windward side of a range often receive abundant snowfall. The air is wrung out like a sponge, drop by drop, flake by flake. But the story doesn't end at the peak. Once the air crosses the summit, it begins to descend. And as it descends, it warms, compressing as it sinks into higher pressure at lower elevations. Warmer air can hold more moisture, but it has none left to give. The result is a dry zone, often sunny, often stark, on the leeward side of the mountain. This is the rain shadow, or in winter, the snow shadow, a place where snow seldom falls, even while the other side of the same mountain lies under deep drifts. You may see this in the Cascade Range, where lush forests and heavy snows blanket the western slopes. But the eastern side opens into dry valleys and high desert, or in the Rockies, where towering peaks catch winter storms, and the leeward plains rest beneath clearer skies. The contrast can be sharp, a winter wonderland on one side, and bare ground just over the ridge. Snow shadows aren't cold. They can be warmer than surrounding areas, thanks to descending air that dries and heats. This effect is sometimes called a Chinook, or snow eater, wind, common in places like Montana or Alberta, where warm gusts sweep down leeward slopes and melt snow in hours. But even without wind, the presence of a mountain reshapes winter. A single range can dictate where snow will fall and where it will not. It's a reminder that winter is not uniform. It's sculpted, not just by temperature, but by terrain. So tonight, as we drift above the hills and peaks, notice the divide, the edge of snow, the way one side glows white, while the other lies in winter's quiet shadow. Mountains don't just hold snow, they cast it. When warm Pacific moisture streams inland, winter drinks deeply. Tonight, we drift above the ocean, far above the swells and spray, to find a river in the sky. It doesn't glisten like a stream, it doesn't rush like a waterfall, but it flows softly, steadily, invisibly, a ribbon of moisture, thousands of kilometers long. This is an atmospheric river. Unlike the rivers we know on land, this one carries water vapor, not in drops or waves, but suspended in the air. It flows from the tropics, often near Hawaii, across the Pacific Ocean, toward the western coast of North America. Some call it the Pineapple Express, a poetic name for a powerful process. These rivers in the sky are long, narrow corridors of concentrated moisture. They form when warm ocean air meets strong winds in the upper atmosphere. Like conveyor belts, they move huge volumes of vapor, more than the Mississippi River, sometimes 15 times more, across great distances. As this moisture-laden air reaches land, it begins to rise, especially when it meets mountains. This is where the snow begins. The moist air ascends the western slopes of the Sierra Nevada, the Cascades, and the Coast Ranges. As it climbs, it cools, and cooling air cannot hold as much moisture. The result? Condensation, cloud formation, and copious precipitation. When temperatures are cold enough, and in the high elevations of winter, they often are, this moisture doesn't fall as rain, it falls as snow. Not just a dusting, but a feast. Feet upon feet of fresh powder can accumulate from a single atmospheric river event. Skiers celebrate. Reservoirs are quietly replenished. mountains glisten with a fresh coat of winter's offering. These events don't always arrive with drama. Sometimes the snow falls gently for hours, thick, steady, without pause. Other times, the river surges, bringing heavier bands of moisture and intense snowfall rates. Meteorologists track these sky rivers with satellites and radar. They look for long filaments of moisture winding their way across the ocean, headed for land. Forecasting their arrival helps prepare for heavy snow, potential flooding, and water supply gains. Atmospheric rivers are not rare. On average, they account for 30 to 50% of the annual precipitation in parts of the western United States. They are essential to the winter snowpack that nourishes spring and summer. But they require balance. A gentle, well-timed river brings life. Too many in a row, or too warm an arrival, can bring flooding and melt instead. Still, when they align just right, they become quiet heroes of the season, skyborne streams that fill our rivers, nourish forests, and blanket the mountains. So, tonight, imagine a river that flows without sound, high above the waves weaving across the sky, carrying winter's nourishment from sea to summit, a stream of air, a ribbon of life, flowing gently through the heavens. Beneath a blanket of snow lies the future of rivers. Tonight, we sink softly into the snow, not just to admire it, but to understand its weight, its silence, and its promise. Beneath this still surface lies something powerful, something that waits. This is the snowpack, winter's hidden reservoir. When snow falls and gathers across hills, valleys, and mountains, it begins to accumulate, storm by storm, flake by flake. What begins as light powder slowly settles, compresses, and becomes a deep, dense layer of stored water. Unlike rain, which runs off quickly, snow takes its time. It holds water in slow motion, frozen, suspended, and patient. And as spring arrives, this snowpack begins to melt, feeding rivers and streams, recharging aquifers, and sustaining ecosystems far below the mountaintops. In many regions, especially the American West, up to 70% of the annual water supply comes from melting snowpack. It is, quite literally, springtime's lifeline. But not all snowpack is equal. Its depth and density determine how much water it contains. A foot of fluffy, low-density snow might melt into only an inch of water, but a foot of dense, settled snow can hold 3 or 4 inches, sometimes more. To track and predict this, scientists monitor snowpack closely. They hike or ski into the mountains with long snow tubes, plunging them into the drifts to measure what's called the snow water equivalent, the amount of water contained in the snow. Others use snow pillows, large platforms that measure the weight of snow from below. Satellites, too, scan snowy landscapes to estimate snow coverage and trends from space. All of this helps answer a critical question. Will there be enough water when the snow melts? In good years, the snowpack is generous. It melts slowly, steadily, feeding streams and filling reservoirs. Wildflowers bloom, fish spawn, farms thrive. In lean years, the snowpack may be thin or melt too quickly. Rivers shrink, drought deepens. The memory of winter disappears too fast. Climate shifts can also affect snowpack, bringing more winter rain instead of snow, or warmer springs that trigger early melt. The timing matters as much as the total. But for now, the snow rests, layered, pressed, preserved. Walk through a quiet forest in February, and you're stepping over liquid time, water, sleeping in crystalline form. Not lost, just waiting. So tonight, Picture that weight beneath your feet. Not heavy, but full. A gentle burden, a quiet gift. Snow that fell softly weeks or months ago, now layered and ready for the sun. And when spring comes, it will flow. Clear, cold water, born of silence drawn from snowpack. Winter's reservoir of life. Neither snow nor rain, these forms fall in between. Tonight, we explore the in-between. Not snowflakes, not raindrops, but something quieter, more delicate, more subtle. These are the gentle intermediaries of winter, sleet and freezing drizzle. Weather that doesn't fall in grand, sweeping gestures, but in patient, precise drops of frozen transition. To understand them, we drift through the layers of the atmosphere. High above, precipitation usually begins as snow. Tiny ice crystals form in cold clouds, clustering and growing. But as the flakes fall, they pass through a changing sky, a vertical landscape shaped by temperature. Imagine falling through a warm layer, tucked between colder air above and below. If this warm layer is thick enough, the snowflake melts completely into rain. But what if, just before reaching the ground, the air turns cold again? If that cold layer is deep, the raindrop has time to refreeze in midair. It becomes a small, hard pellet of sleet. You'll know it by its sound, a soft tapping on windows, a tiny bounce on sidewalks and railings. Sleet is frozen before it lands. Each pellet is like a bead of glass, glittering but firm. It can accumulate like snow, but is denser, crunchier, and often harder to shovel. On roads, it becomes a challenge, slick like ice, but textured like hail. Now let's soften that scene. What happens when the cold layer near the ground is very shallow, too thin to freeze the raindrop before it lands? Then, the drop stays liquid, but just barely. And when it touches a surface below freezing, it freezes instantly on contact. This is freezing drizzle. Unlike sleet, it doesn't bounce. It clings, a fine mist that turns to ice on tree limbs, walkways, windshields, even the tiniest twigs. Because it falls so quietly, freezing drizzle often surprises us. A morning sidewalk that looks wet is actually icy. A railing that seems harmless becomes slippery with a hidden glaze. These in-between storms are often overlooked. They don't bring the spectacle of blizzards or snow squalls, but they demand attention in their own way. They are the artists of winter's transitional layers, the result of temperature stacked in subtle contrasts. Warm, cold, then warm again, a dance of degrees. Meteorologists watch closely for these setups. They examine vertical temperature profiles from weather balloons and computer models. A few degrees difference at just the right altitude can decide whether a region gets snow, sleet, or freezing rain. And to those who listen closely, each has a voice. Sleet whispers in taps and clicks. Freezing drizzle speaks in stillness, a silence before the shimmer. So tonight, if you hear the soft patter of sleet, or wake to find the trees wrapped in invisible ice, know that you are witnessing one of winter's most delicate transitions. Not snow, not rain, but the poetry of something in between. How do meteorologists know when to alert us? Tonight, we step behind the scenes, into the quiet rooms and glowing screens of forecasters, those who read the clouds before they form and speak the language of storms before they arrive. In winter, weather moves with silence and softness, but sometimes it carries weight. And that's when we listen for alerts, watches, warnings, advisories, each one a whisper of preparation, a nudge to pay attention. Let's begin with a watch, a winter storm. Watch means conditions are favorable. Not certain, but possible. The ingredients are gathering: cold air, moisture, and lift. A storm may arrive in the next 24 to 72 hours. Watches are quiet anticipation. They tell us something may come. Stay aware. Next comes a warning, a winter storm. Warning means the event is imminent or already happening. Snow, sleet, or freezing rain is expected to reach thresholds that impact travel and daily life. Typically 4 to 6 inches of snow, or significant ice accumulation, depending on region. Warnings mean the storm is here. Prepare now. Then there are advisories, issued when conditions are less severe, but still capable of causing disruptions. A winter weather advisory might be issued for lighter snow, patchy freezing drizzle, or brief bursts of sleet. It means it won't be dangerous for everyone, but take care. But how do forecasters decide? They rely on models, computer simulations of the atmosphere built from current observations. These models digest thousands of data points: temperature, wind, humidity, pressure, satellite scans. Multiple models are compared. Forecasters look for agreement, for timing, for signs of change. They also study radar, watching moisture bloom and shift in real time. They read the soundings, vertical snapshots of the atmosphere from weather balloons. But beyond the data, there is something more: experience. Forecasters learn how certain regions respond to snow, how one town's elevation collects snow, while another's valley floor sees only rain. They must balance science and caution, announce too early, and people tune out, too late, and people are unprepared. So, when you hear the words on the radio, or see them scroll gently across the bottom of the screen, know that they were chosen with care, issued not to startle, but to guide, and they are always softened by your own judgment. What's safe, what's cautious, what's right for your home. Watches, warnings, advisories, they're the lullabies of preparedness, the early whispers of something that may arrive or pass you by entirely. So tonight, rest easy. Let the forecasters watch the sky while you dream, because if the snow comes, they will let you know, calmly, gently, sleepily. Why are some places colder than others? Tonight, we float gently over rooftops dusted with snow, past frosted trees, icy rivers, and windows glowing warm against the chill. Beneath us, cities sleep under winter's breath. Some shiver through a few weeks of frost. Others rest in deep cold for months. Why are some places so much colder than others? The answer, like most things in meteorology, begins with location. The first factor is latitude, how far north or south a place sits from the equator. Cities closer to the Arctic Circle receive less sunlight in winter, and when the sun does rise, it stays low in the sky. Its light spreads thin across the land, and little warmth is gained. Norilsk, Russia, for example, one of the coldest cities on Earth, sits well above the 60th parallel. In the heart of winter, the sun barely peaks above the horizon. Temperatures can plunge below -30 degrees Fahrenheit for days or weeks. But latitude is only the beginning. Elevation plays a role too. The higher you go, the thinner the air, and the colder it becomes. Cities perched in mountainous regions may feel winter's chill even when located closer to the equator. La Paz, Bolivia, and Lhasa, Tibet, are high-altitude cities that experience cold, crisp winters, not from latitude, but from altitude. Then there's geography, the land around a city. Is it nestled in a valley where cold air collects and lingers? Or is it exposed on a plain where wind sweeps freely? Valleys can act like bowls, trapping cold air and preventing it from mixing with warmer layers above. Inversions form, temperatures fall, and the cold holds on. Now, consider the presence or absence of water. Large bodies of water, like oceans and lakes, moderate temperature. They cool slowly and warm slowly. Cities near coasts often experience milder winters because the water buffers against extremes. But move inland, far from the ocean's embrace, and temperatures swing more dramatically. Ulaanbaatar, Mongolia, holds the title of coldest capital city in the world. Located deep within the Asian continent, far from the warming influence of water, its winters are long, dry, and unforgiving. January temperatures average below -20 degrees Fahrenheit. Yellowknife, in Canada's Northwest Territories, is another city that endures deep winter. Perched on the edge of Great Slave Lake, it combines high latitude with inland chill, earning weeks of sub-zero quiet. But it's not always just latitude or elevation. Wind patterns, snow cover, and even urban design shape a city's winter. Snow reflects sunlight, so when a city is snow-covered, it holds on to the cold. The streets stay shaded, the ground cools, the air above it becomes a little more still. Even the design of buildings, how tightly they're packed, how high they rise, can change how heat is trapped or lost. Some cities adapt. They build insulated homes, heated sidewalks, or underground passageways. Others embrace the cold as part of life, with festivals, skating paths, and warm food shared by glowing fires. So tonight, as we float over icy rooftops and sleeping towns, we see that cold is not random. It is shaped by sky, land, and sea, by tilt, by wind, by distance and depth. Some cities live under winter's breath for just a while. Others wear it like a second skin. And in every one, the cold tells a quiet story of where it comes from and how it stays. As the longest night passes, the sun returns slowly. Tonight, we drift into a turning point, a pause in the planet's rhythm, a whisper of change, barely felt, but deeply real. This is the winter solstice, the longest night of the year. At the solstice, the northern hemisphere tilts farthest away from the sun. The sun's path across the sky is the shortest it will be. It rises late, sets early, and arcs low, casting long, gentle shadows. But something beautiful happens in this moment of maximum darkness. The light begins to return. Each day after the solstice, the sun lingers a little longer. Not by much at first, perhaps just seconds, but like snowflakes, those moments accumulate. It's the start of a quiet reversal. The earth, still wrapped in cold, begins its slow lean toward spring. But why, if the sun is returning, does winter begin now? The answer lies in timing. The planet takes time to respond. Even though the sun begins its climb, the northern hemisphere continues to lose more heat than it gains, at least for a while. Snow cover reflects sunlight. Nights are long and skies are often clear, allowing warmth to escape. The ground is cold. The oceans, even slower to change, are at their coldest weeks after the solstice. This delay creates the heart of winter. January and February bring the deepest cold, even as the days begin to stretch. But the solstice is a promise, a marker on the calendar of the sky, a moment when the tilt begins to lean back, and the Earth's face slowly turns toward light. In ancient times, people watched the solstice with reverence. They lit fires, built monuments aligned to the sun's rise. They knew, even without instruments or models, that the light was returning. Today, we mark it quietly. Maybe we light a candle. Maybe we step outside and notice how the sun rests low on the horizon at noon. Maybe we just feel it, that subtle shift. In places far north, where daylight nearly disappears, the solstice is especially precious. It's the turning point toward sunrise, the beginning of the end of the long night. So as you rest tonight, beneath the stillness of stars, know that this is the darkest point, and that from here, the days will lengthen. Snow may still fall, winds may still chill, but above the clouds, the sun is climbing 1 degree higher, 1 moment longer. The solstice is not loud. It's not rushed. It's the Earth's quiet turn toward warmth, a celestial breath inward, followed by a slow, glowing exhale. And with it, the promise that even the deepest winter leans toward light. Not all snow feels the same. Tonight, we reach down with gloved hands, not to gather science, but texture, to feel the winter beneath our boots and mittens. Because snow is not just white, it's substance. And every flake, every drift, tells us something about the air it came from. There are 2 main personalities of snow: powder and packing. Let's begin with powder, the lightest, driest form of snow. It falls when the air is cold and crisp, typically below 28 degrees Fahrenheit, minus 2 degrees Celsius. And it's born of low moisture content. Powder snow forms when snowflakes grow in dry, chilled clouds. The flakes are complex, stellar dendrites with intricate arms, but they remain separate. They don't melt, they don't cling. They tumble gently, landing softly, flake upon flake, creating drifts of fluff that float on the wind. Step into powder, and you sink with silence. It squeaks underfoot. It brushes easily from branches and sleeves. Skiers and snowboarders call it the perfect snow, because it cushions, glides, and never sticks. But powder is fragile. It can't be packed into balls or rolled into snowmen. Try to grab it, and it sifts through your fingers like sand. Now, let's meet packing snow. Heavier, stickier, still soft, but with weight. Packing snow falls when temperatures are warmer, around 30 to 34 degrees Fahrenheit, minus 1 to plus 1 degrees Celsius. The flakes may begin as dendrites, but as they fall through moist, slightly warmer air, they partially melt. This slight melt causes the flakes to stick together, forming clumps. The result is a wetter snow, rich in liquid water content. When you gather packing snow in your hands, it holds its shape. You can form snowballs, build forts, craft snowmen with rolling, stacking satisfaction. It falls heavier from the sky. You can hear it patter, feel it land on your coat with more presence. Underfoot, it crunches, not squeaks. It clings to boots, fences, and rooftops. It's the kind of snow that coats tree branches in thick, white frosting. A sculptor's snow, full of possibility. The difference between powder and packing comes down to a delicate balance, temperature, humidity, and the journey the snowflake takes as it falls. A flake that begins high in cold, dry air may fall into a warmer, wetter layer, shifting its shape and bonding with others. By the time it reaches the ground, it has changed, its texture transformed by its descent. Meteorologists describe these variations with a ratio, the snow to liquid equivalent. Dry, powdery snow may have a ratio of 15 to 1 or even 20 to 1, meaning 20 inches of snow would melt into just 1 inch of water. Wet, packing snow might fall at a 5 to 1 ratio, heavy and dense. So the next time you catch snowflakes on your glove, notice how they behave. Do they flutter apart in a soft whisper? Or do they cling together in sticky clumps? Both are winter's gifts. Both carry a message from the sky. One is light as breath, the other full of form. Powder and packing, two textures of snow. Two poems written in crystal. On snowy slopes, layers can shift. Tonight, we climb carefully into a landscape of quiet tension. Not a storm, not a squall, but a sleeping slope where stillness holds weight. This is the story of the avalanche, a sudden release in a place that seemed perfectly at rest. To understand avalanches, we must first understand snowpack. When snow falls on a mountain, it arrives in layers. Each storm brings a new blanket, different in texture, temperature, and weight. Over time, these layers stack. Some bond well, others do not. Beneath the surface, the snow is not solid, it's stratified. A quiet history of storms and stillness written in bands. Some layers are light and airy, others are dense and hard, and sometimes a weak layer lies buried within, fragile, unstable, delicate. Avalanches occur when the weight of the upper layers becomes too much for the weak layer to hold. It collapses, and the snow above it begins to slide. Not always with a roar. Sometimes just a sudden shift, a graceful, soundless release. Most avalanches happen on slopes between 30 and 45 degrees, steep enough for snow to move, but not too steep to hold nothing at all. And they're often triggered not by storms, but by small changes, the added weight of fresh snow, the warmth of a sunny day, a skier's passing, or even a voice. Yes, sound and motion can sometimes disturb the balance. What seemed stable becomes undone. Avalanches come in several forms. Slab avalanches, where a wide, cohesive sheet of snow breaks away as a unit. These are often the most dangerous, carrying immense mass and speed. Loose snow avalanches, which begin at a single point and fan outward like a waterfall of flakes. Less powerful, but still fast and beautiful in motion. Wet snow avalanches, triggered by meltwater weakening bonds within the pack. More common in late season, slower but heavier. Forecasters study snowpack daily in mountainous regions. They dig snow pits, examining each layer by hand, testing for stability, measuring hardness, and feeling for the telltale give of a weak layer. They issue avalanche warnings and risk assessments, helping climbers, skiers, and mountain communities stay aware. But even with all our tools, avalanches remain mysterious, a combination of physics and snowflake memory. They remind us that even in stillness, tension can build, and that beauty and risk can share the same space. Yet, in this knowledge, there is no fear, only respect, for the mountain, for the snow, for the quiet forces beneath. So tonight, picture a snow-covered slope beneath moonlight, peaceful, majestic, and heavy with stories. And beneath that beauty, a layered world of snow in waiting. Not always to fall, but always to remember. Humans work with snow, not against it. Tonight, we walk along quiet roadsides and frozen rail lines, noticing something that at first seems ordinary. A line of slatted wooden fences, standing alone in snowy fields. They aren't for cattle. They aren't for privacy. These are snow fences, humble tools used to guide the wind, and in doing so, shape the snow. Winter snow doesn't just fall straight down. It dances, glides, tumbles sideways, especially when light and dry. When wind moves across snowy ground, it picks up loose flakes and drifts them along, creating waves, ripples, and sometimes towering mounds. These snowdrifts often gather where wind slows, behind buildings, along roadsides, across railways. Left unchecked, they can bury paths, block visibility, and create slippery hazards. So, we don't stop the wind. We guide it. That's where snow fences come in. A snow fence isn't built to block snow like a wall. Instead, it's designed to slow the wind just enough. When wind carrying snow passes through the slats, it loses speed. And when the air slows, the snow settles. The drift forms not on the fence itself, but just downwind, often 30 to 50 feet away, like a ripple behind a rock in a river. By placing fences strategically, we encourage snow to drift where we want it to, in open fields, not on roads, along ditches, not across highways. It's choreography, an elegant collaboration between physics and design. The best fences are porous, around 50% open. Too solid, and the wind simply flows over, carrying snow farther. Too open, and nothing changes. In flat regions with strong winds, like the plains of the Midwest or snowy provinces of Canada, snow fences are part of winter's silent infrastructure. Some are made of wood, some of plastic mesh. Others are built from lines of trees or shrubs, a living barrier called a shelter belt. These natural fences serve the same purpose. They disrupt the wind, breaking its grip just enough to set the snow down gently. Engineers calculate fence placement based on average wind direction, snowfall rates, and terrain. It's a science of anticipation, and yet it's deeply poetic, using wind's own behavior to shape the world. We don't stop the storm, we don't push against it. We listen to its patterns and adjust. Snow fences remind us that winter isn't an enemy. It's a force to understand, a partner in the quiet art of balance. So the next time you see a wooden fence in a white field, standing alone, with a drift curled neatly beyond, know that it's there on purpose. A gentle hand guiding snow, a soft edge placed by thoughtful minds, a human whisper in winter's wind. This chapter gently explains how the body reacts to extreme cold. Tonight, we turn inward, not to weather patterns in the sky, but to the quiet weather inside the body. Because winter doesn't only touch the land, it touches us. And our bodies, wise and adaptive, have ways of responding to the cold. Let's begin with frostbite. When exposed skin meets extreme cold, the body makes a decision: preserve the core. To do that, it reduces blood flow to the extremities: fingers, toes, ears, and nose. These areas lose warmth faster, and if the cold is intense or prolonged, the tissue begins to freeze. Frostbite often begins with numbness, a prickling sensation, then silence. The skin may turn pale or waxy. If warmth doesn't return, deeper layers freeze and damage sets in. But it doesn't happen instantly. There is time to notice, time to protect. Layers help: gloves, hats, scarves. Anything to hold warmth in, anything to slow the cold's advance. Now, let's drift deeper into the body to understand hypothermia. This is not about fingers or toes, but about the body's core temperature, that steady warmth of around 98.6 degrees Fahrenheit, 37 degrees Celsius, that keeps all systems flowing. When that core temperature drops below 95 degrees Fahrenheit, 35 degrees Celsius, hypothermia begins. The body, ever alert, tries to warm itself. First comes shivering, a gentle tremble, then more intense. Shivering is the body's built-in heat generator, muscles contracting quickly to create warmth. But if cold exposure continues, shivering may stop. The body slows, thought becomes clouded, movements become uncoordinated, a deep fatigue sets in. This is the quiet danger of hypothermia. It arrives softly, without pain, just a slow sinking into cold. But again, there is time. Warmth can be restored. with dry clothing, shelter, warm drinks, and heat close to the body. Often, the greatest protection is simply not being alone, to have someone notice, someone care. We speak of these things not to bring fear, but respect. The cold does not shout, it whispers, it signals through signs, shivering, numbness, pale skin, slowed speech. If we listen, we can respond. Layer by layer, step by step, with care, caution, and kindness. So tonight, wrap the blanket close. Feel the comfort of warmth, not just as temperature, but as safety. Know that your body is wise, that it understands winter, and that in every breath it is working to keep the spark of warmth alive. The cold may say some whisper, but we are listening. Even without new snow, winds can revive what has fallen. Tonight, we step into a curious quiet, a sky that seems clear, a forecast that speaks of calm, yet around us. Snow swirls and lifts, dancing again after it had long settled. This is the world of the ground blizzard, a weather event not born from new snowfall, but from the resurrection of the old. Snow, you see, never truly rests, especially the dry, powdery kind, the kind that fell days ago and never melted. It lies in wait, featherlight on open fields, resting in drifts and thin, fragile layers. And then, the wind returns. It doesn't take much. A steady breeze across flat terrain, the open plains of the Dakotas, the prairies of Canada, or the tundra of Siberia. Places with no forests to catch the snow, no hills to slow the gusts. The wind begins to lift the flakes again, not from the clouds, but from the earth itself. This is not snowfall, it's snow stirred. The particles rise just a few feet at first, a shimmering mist at the surface, then higher, swirling around ankles, knees, shoulders. In strong winds, they can rise dozens of feet into the air, turning open roads into white tunnels, even though not a single flake is falling from the sky. Visibility vanishes. The horizon dissolves. You may look up and see stars, but look ahead and see only white. This is what makes ground blizzards both mesmerizing and misleading. Above, the sky may be perfectly clear. No clouds, no storm. Yet, around you, a blizzard. There are 3 types of ground blizzards, each with its own quiet choreography. Horizontal advection. Wind pushes snow across the ground in a fast-moving sheet. This is the most common type, and often the most disorienting. Vertical advection. Stronger winds lift snow upward in whirls and waves. Visibility drops sharply, even in broad daylight. Thermal mechanical mixing. A combination of surface winds and warm air, aloft, creating turbulent movement that stirs snow in all directions. These events can last minutes or hours. They can arrive suddenly and pass just as fast. Travelers might begin a drive in sunlight, and then, within a mile, enter a storm that was never forecast, because the storm was already on the ground, waiting for wind. Ground blizzards are more than wind and powder. They are echoes, the return of snow to the sky, not as a new storm, but as memory. Even the footprints you left in the snow may vanish, blown away by air that reclaims winter's canvas. And yet, there's beauty in this too, because the snow, like the wind, moves in cycles, drifting, settling, lifting again. It reminds us that weather is not just something that happens overhead. It lives all around us, on the ground, in the trees, in the stillness, waiting. So, if you ever find yourself in a whiteout beneath a blue sky, know you are witnessing snow's second life, a quiet revival. A soft return, not a storm, but a reminder. We return to the beauty of snowflakes, now with a deeper appreciation. Tonight, we drift once more into the crystal quiet of falling snow. Not for the first time, but with new eyes, a second look at something we thought we understood. We return to the snowflake, this time not just to observe its beauty, but to listen to its story more deeply. Each snowflake begins high in the clouds as a tiny speck, a nucleus of dust, salt, or pollen. Around it, vapor gathers and freezes, branching outward in symmetry and silence. 6 arms grow in harmony, always 6. This is the nature of ice crystals, formed by the molecular structure of water. Water molecules arrange themselves in hexagons, a shape both simple and profound. As more vapor freezes, these arms extend, mirroring each other, yet never perfectly the same. Because while the geometry is symmetrical, the journey is not. Each flake passes through layers of air, some warmer, some colder, some damp, some dry. And in each layer, the flake is shaped. It may grow thin plates or tall columns. It may blossom into dendrites, with arms that look like feathers or ferns. There are over 35 known forms of snowflakes, and likely many more yet unnamed. Each one is a sculpture, not of marble, but of time, temperature, and vapor. Scientists have studied snowflakes with electron microscopes, photographing them in mid-air, cataloguing their forms like works of art. And yet, despite all this, no two are ever truly alike. Because each flake's path is unique, its life is seconds long, but full of motion, and just as it forms, it also disappears, landing on a mitten, melting into a sleeve, falling to the ground and vanishing into the drift. A snowflake is a vanishing sculpture, perfect, then gone. We may try to catch them, to photograph, to hold, but the beauty lies in their impermanence, in the fact that they are made only to fall. And perhaps that's the lesson snowflakes carry, that something can be momentary and still meaningful. That symmetry need not be permanent to be real. That beauty often happens once, and that once is enough. So, as snow falls tonight, let it land gently on your sleeve. Look closely, not just with your eyes, but with your wonder. And if it melts, let it melt, because even in its fading, the snowflake has spoken. In geometry, in silence, in grace, it was here. Some storms earn names. Tonight, we consider something quiet, yet curiously human. The habit of giving names to weather. Not to every snow, not to every breeze, but to the storms that leave footprints. We name them not to fear them, but to know them, to give shape to something vast. In the world of hurricanes, naming is long established. Alphabetical lists prepared in advance. Storms named by international agreement. But for winter storms, the practice is different, softer, newer, more debated. In the United States, it was the Weather Channel that began naming winter storms in 2012. Names like Nemo, Juno, Jonas, and Uri began to appear on broadcasts, headlines, and in everyday conversation. Unlike hurricanes, winter storm names aren't issued by a government agency like the National Weather Service. Instead, they're assigned by private meteorologists and broadcasters, a way to track significant systems, to help the public recognize and remember. The criteria vary. Typically, a winter storm must be expected to meet certain thresholds: heavy snowfall, dangerous ice, widespread impact across states or regions. Not every snowstorm earns a name, but those that do often linger in our memories. Think of Winter Storm Uri in 2021, a powerful system that swept across the US, bringing snow and freezing temperatures as far south as Texas. Or Juno in 2015, whose name echoed through the Northeast as it buried cities in snowdrifts and silence. Names create a shared story. They allow us to speak about a specific moment in weather, to mark it in time, not just as that big snowstorm, but as Nemo or Magnus or Olive. Still, the practice has its critics. Some meteorologists argue that naming may cause confusion, especially when different regions or stations use different standards. But names, like snowflakes, settle differently depending on where they land. And in many places, they offer clarity, a single word to hold 1,000 flakes. Names carry memory. Long after the snow melts, people recall the name. They tell stories. That was during Jonas, remember the drifts. We lost power in Maya. Uri shut everything down. The name becomes a shorthand for experience, a label for something felt and shared. Other countries use their own naming systems. In Europe, national meteorological agencies may name significant storms, sometimes even coordinating across borders. Each name becomes a marker of record, catalogued, studied, remembered. But perhaps more than anything, naming storms is a reflection of our need to connect, to understand, to make something vast feel closer, to speak about weather not as an abstract force, but as something with a name, something that passed through, left its mark, and moved on. So tonight, if you hear a name in the news, and it's not a person, but a storm, know that it's part of a soft language, a human habit, meant to hold the snow in story. And finally, we watch winter melt. We have drifted through frost and flurry, wind and whisper, crystal and calm. Now, we reach the moment when the season begins to exhale. This is the melting point, that gentle turning when winter softens. It doesn't happen in a single day, not with a rush or roar, but with a slow release. The snow, once crisp and powdery, grows heavier. Its edges blur. Drips echo from rooftops. Icicles lengthen, then vanish. You might notice the first sign in sound, the return of water, a slow trickle through downspouts, the quiet gurgle of thawing creeks, the rhythmic tap, tap, tap of melting snow. The sun rises just a little higher now. Its warmth, still pale, begins to linger on your shoulders. Shadows shift. Colours return to the landscape, subtle at first. A hint of earth beneath the slush, a pale green whisper beneath the frost. This is transition. Not yet spring, but no longer deep winter. Meteorologists track this change in degrees. A few days above freezing. Overnight lows that hover near the cusp. The freeze-thaw cycle begins. Melt by day, refreeze by night. It shapes the snow into new forms. Pocked, crusted, glazed. What was once soft and smooth becomes textured. And yet, it's beautiful, because this too is part of winter's rhythm. The melting point is not the end, it's a passage, a handoff between seasons. The atmosphere loosens, high-pressure systems shift, jet streams rise. Moisture returns in the form of rain, not snow. And still, winter lingers in morning frost, in shaded hollows, in quiet memories. But the light has changed. There is softness now. Birdsong returns. Windows crack open. Scarves hang unused near doors. Even indoors, the body feels the change. You breathe a little deeper, stretch toward the window, sense that something is leaving, and something new is near. The snow melts not just from the ground, but from the air. The feeling, the silence, the hush, all begin to lift, and with them comes hope, not urgent, but tender. So tonight, we close our eyes under a sky no longer heavy. We listen to the last sighs of snow. We rest in the soft embrace of a season that has held us gently. And we wait, not impatiently, but peacefully, for the whisper of spring. And as our journey through winter winds down, I hope you felt the quiet beauty hidden in every flake, every frost, every whisper of cold. Together, we've wandered through snowdrifts and still skies, listened to the hush of falling snow, and marveled at the silent architecture of ice and air. May the wonder of snowstorms and soft skies stay with you, not as weather to be braved, but as calm to be carried. If these gentle meteorology journeys bring you peace, you're always welcome to like or subscribe, but only if the moment feels right. Your quiet presence here means more than you know, truly. Now, let your breath slow. Let the snow continue falling in your mind's eye, soft, endless, and serene. The kind of snow that hushes the world without asking for anything in return. Snuggle deeper into warmth, even as the world glistens cold beyond your window. Good night, dear friend. Peaceful dreams, and calm skies to you, always.